In this lesson, we'll focus on how we store all of that data and what happens when we don't want it anymore. This will bring up some concerns about privacy versus convenience and utility that may require you to rethink some of your online practices. So the question is, what about all of this unstructured data that we've been talking about, like the web? We said that the web was actually kind of a mess and is a great example of unstructured data. We've seen that spider bots crawl around the web and generate metadata, which is the data about the data. They index web pages and all of that. So how can we use this to aid in retrieving information from an unstructured data source? So now we have to actually take a step back and think about, okay, I'm trying to extract data from an unstructured source, and we have all of this data, so how exactly is it stored? Well, really big data processing companies like, for example, our friends at Cambridge Analytica have data centers that are capable of holding upwards of 50 plus petabytes. Okay, that's like a quadrillion bytes of information. That's enough space to hold over 25 trillion pages of text, the entire contents of the Library of Congress, times 179, right? That's a lot. That information, remember, that all used to be on paper, all right? And the amount of information that you could hold on paper would be the equivalent of 2.5 trillion trees. Right? Thank goodness for digital data storage, right? If you think, for example, about online games, massive multiplayer online games and things like that, people at those companies are constantly collecting data from everybody playing that game. And it's a lot. So we get to a point where something like a relational database or any traditional type of database might not be enough to hold all that data. The amount of data created is growing exponentially. And so is our ability and our prowess at collecting and storing the data. How do we get all the space? All right, can we just continue indefinitely to collect and store big data and hope that it's useful sometimes as the collection of data grows and grows? Storage structure can help us access and utilize this data more efficiently, right? We talked about structuring the data, but when do we get to a point that it's too much? All right, so let's look at how storage structures could impact something like a chunk of text. All right, so on the left, you can see a raw chunk of text. Could we use metadata? Could we use data about this data to store it in a way that would be less than the original, right? That's what it's all about, right? Trying to compress. So if we want access to this document based on length, how many letters, how many words, how many lines, we could do that. That would actually make it really easy. It's 12 lines. We could save it as 12. Not quite the same, right? Instead, we could do something like what you see over on the right. So we could say, well, there's 7 occurrences of the word gotta. We can argue about whether gotta is really a word or not, but there are 7 occurrences of that text string. Apparently there are only 5 instances of the. And anyways, so you can see that if we applied a method like that, then we could actually store this data in less space. What would that accomplish? How useful is this, and how on earth would we put it back into its original form if we wanted to, right? Who knows what the solution is here. What we want to know is if we want to know something like this, like how many instances are there of each individual word, each unique word that occurs in this text, we could store it like this. That would be great. And we could look it up. We could look up and see how many times. But it doesn't help us understand what this means, right? There's not a lot of meaning to be had from this. I could draw certain conclusions about it. I could say that it does happen to have a lot of, we could say, incorrectly spelled words, so this is maybe more like speech or singing, something like that. So I can draw some conclusions, but I can't tell what the text means. That's just an example that these metadata storage structures do require less space, but are maybe less useful. So one type of storage structure that we can use is an index. All right, and you've got experience with indexes. Almost any textbook that you have, whether it's paper or digital, you can go to the back of the textbook and you can access this index of concepts. Maybe they are words, but, I want to find out where in this book, a certain concept occurs, adaptation. All right, and it tells me, well, it occurs on this page, and maybe it might give you a little bit more information than that, but not much. All right, so, and according to dictionary.com, an index is an alphabetical list of names and subjects with references to the places where they occur, typically found at the end of a book. The web isn't a book, but search engines use this exact same concept. They create indexes, just like you learned with the SpiderBot activity. Why do search engines search through a generated index of pages rather than the actual pages themselves each time a search query is performed? Why aren't they going through all of the page? Why aren't they doing the search at that moment to try and pull out relevant results? Well, the answer is it is just far more efficient to use an index, okay, to use indexes. All right, and that's really the answer. Could they do it the other way, in real time, actually searching page after page after page, looking for your particular keyword or whatever it is that you searched? Yes, they could do that, but it would take a lot more time. All right, it is far more efficient to search by an index. Okay, so just like the index of a book, the purpose of a search engine index is to generate a set of concepts or keywords and link them to a set of web pages and locations on the web where those words are referenced. All right, so imagine that you needed to search for information about the word link in the book Blown to Bits. Obviously, the most efficient way to find it would be to go to the back in the index, look up links, and you might find a couple of different references, links used in a couple of different ways, and you'd select the way that you meant to use it, and you would find what page to go to find it. All right, and that is much easier than the alternative, which is let's start at page 1 of Blown to Bits and skim and hope that we catch any occurrence of the word link so that we can read about it, right? That would be awful. And worst of all, every time you need that same information again, you would have to perform the same steps unless you were creating an index of your own, right? And having an index solves that problem. So indexes aren't necessarily the only way that we can organize data. All right, so computing actually allows us to efficiently create what we call a concordance also. All right, so the question is, well, what's different? Interestingly, when I look at this, I can already tell that it's different from an index because it has listed, I can see heart, singular, and it also lists hearts, plural. Now, I wouldn't probably have that in an index unless the singular and the plural were like two completely different concepts, right? So that's one kind of giveaway that this is a different animal here. An index is a list of conceptual topics paired with their location, whereas a concordance is actually the actual individual words with their location, regardless of what that word means and whether it means kind of the same thing as one of the other words. All right, so it has nothing to do with concepts and everything to do with the specific word. Interestingly, concordances have been used even before computers. Concordances were done, and it was a really, really, really time-consuming and painstaking process to create a concordance. Really, really big literary work, namely the Bible, have had concordances created of them, even pre-computer, and certainly post-computer now that this is able to be done digitally. Additionally, attorneys, people in the legal profession tend to use concordances because they want to find obscure court cases that match the thing that they're dealing with at a particular time. So those are some examples of concordances being used off the computer. But certainly now that we have computers, those concordances have been done so that those searches can be done digitally. A concordance is actually fairly easy, maybe even easier than an index to generate computationally, since basically all you're doing is pattern matching a bunch of text. Basically, what we're saying is, like up here in the top example, find all occurrences of, and we could use the word link, in blown to bits, right? And we would get all kinds of things. We would get maybe not just hyperlink, which is maybe how we meant it, but we might get links between two concepts, links between a particular privacy concern and an effect of, something. So we might actually get more than we bargained for if we use a concordance, because we're just looking for a specific word. But if we look it up in the index, somebody has already found the occurrence of the word and they've analyzed its use in context. All right, and so what you're looking at is more a list of the concepts. Okay, so with a concordance, those concepts don't matter. And it can be more, if you really are looking for individual words because you want to find out, like, what other words usually occur with the word link. And then you might find the word hyper in there, right? So if you're really looking for the individual words, then a concordance is the way to go. Either one of them takes a lot of work to make. They're both very labor intensive. And so whether it's a human doing the work or a bot doing the work, it still takes a lot. However, in the long run, indexes save time because, and we talked about how searching it, you would never start blown to bits page 1 searching for a particular word. You would instead go to the index, and it will take a lot less time. So that's the same concept on the web. Indexes save time in the long run with searches. However, with an index, you have to already understand the concept and its context. If you don't already have an understanding of that, then searching in an index, you might go astray. You might not really find what you were looking for. All right? And so on the other side, a concordance can save time in the short term because you can go individually and search word by word by word, and that will save time. But when you find your results, you have to be able to look at that result and know by the context, is this the concept that I was really looking for? And you'll have to ignore it if it wasn't. Okay, so one of them saves you time in the short term, one of them saves you time in the long run. So who knows? I guess it depends on what you're feeling up to. And in one of your post-lesson exercises, you will actually work to build an index. So now that we know ways that we can store data, like how can we keep track of what we have, how does that affect us? So for example, what happens to information that you delete online? I know, you've probably been told over and over about this. So you might think that because you delete a picture that you posted on Instagram or something like that, that it's gone and it will never be seen again because you deleted it off your account. And of course, as we already know, that is not the case. All right, what happens online stays online. It's like Vegas, right? It's going to stay there. Computer scientists refer to this as the persistence of digital data, right? Because that data, even though it's deleted from one place, is almost assuredly going to persist in another place online. Maybe somebody took a screenshot, right? And now it's on their account and on their device. Maybe the service that you use to upload now has a copy of that, right? So you can, in the lesson, there's a link to the Wayback Machine. And I would really suggest, think of a company that's really popular, something like, I don't know, Nike or a particular restaurant. Just because they have updated their website, which surely they have since the 90s or something like that, hopefully they've updated. But just because they have updated their webpage doesn't mean that their old web pages aren't still out there, and you can find them on the Wayback Machine. So it's a good example. It's kind of fun to look at, first of all. And secondly, it's a good illustration of the fact that that data persists. Even though McDonald's might want to forget that this is what their web page ever looked like, we won't, because that data has persisted over time. So if data doesn't go away, and it's always going to be somewhere out there, maybe not even in our possession, now you can start to see a concern. When you sign up for an online service like Facebook, Twitter, Instagram, Snapchat, YouTube, whatever, they are also turning over a lot of that digital data to the company that controls their account. So actually this is how and why these companies exist. So if nobody was posting on Facebook, why would you want to be a part of that particular social media service, right? If there was nothing there to see, nobody's putting anything on, then why would you be there either? All right, so the service only has value because users give their data. But once they give that data, the service owns it now, right? They're free to use that data however it sees fit, as long as it's in accordance with their posted policies and their user agreements. At this point, read the text from Facebook's help page about how you would go about deactivating or deleting your personal page, and think about the following two questions. First of all, which option is more likely to retain your personal data? And does either one of the options actually guarantee that everything you've created and posted will be deleted? Check out that text and then come back and we'll talk about it. So by now you've had a chance to read both of those statements, and deactivation, just by the way they describe it, it sounds more temporary. You're just going to take a break from Facebook. You'll be back after you get over all people's whatever it is that has been annoying you about what they're posting. Too many pictures of people's dinner, too many pictures of somebody's kids, too many political posts, or something like that, right? So you're just going to take a break and you're going to come back when the time seems right. So at that point, great, yeah, because you've probably put a lot of stuff into that, and you've probably put some things that you'd really like to save, that you want to go back and access. You might have forgotten that all the pictures of Nana's 90th birthday party were in there, and you don't have those on your phone anymore, or something, who knows, right? So at that point, data persistence is good, because you went and took a break, and then you came back, and all your stuff was still there, right? So great, thank you Facebook for, or whatever, whatever the account is. Thank you for holding on to that data. All right, so then you would think, okay, well, if that's the temporary one, then the deleting of the account must be permanent, must be really deleted. Like, it's not temporary, it's actually going to delete everything, right? Well, I don't know. If you kind of read the fine print, it says most personally identifiable information associated is removed. Some personally identifiable information may remain. Copies of some material, photos and notes, may remain on our server for technical reasons. Is it really and truly a way of permanently deleting everything that you've put up on that account? Nope, it's not. The data has persisted. So data persists, and there's, it's kind of beyond our control. The only way we control not having data persist online is to not put anything out there. What are the trade-offs? How do you weigh out whether you should or shouldn't put something online? All right, well, you have to look at privacy, the security of your data, versus the utility. Is it useful to actually have your data out there, right? And because maybe it will help you get something back in return, or, find other people who have the same type of data, or, who knows? These are things that we have to consider. A service like Flickr is going to maintain redundant backups. Redundant meaning multiple, right? Done multiple times. Backups of all its data. Just an example of something that you have to think about. That's good, right? If your camera gets destroyed in a flood or something like that, you're going to be really, really glad that those pictures, that those backups are there. But on the other hand, it's out there, okay? You've kind of traded off privacy for utility.